Ladies and gentlemen, good morning for day 2 of this conference. Today is a special day. Yesterday, we celebrated the establishment of a new center on quantum coherent science. Today, we celebrate the achievements of one of the pioneers of quantum coherent science, John Clark. This occasion is doubly pleasurable in that next month is John's 75th birthday. And we wish you many more happy returns of the day, John. I am reading a statement that many members of the department have put together to express our gratitude for all that you've done for this department over the last many decades. To start with a brief history of John Clark. John Clark received his BA in 1964, his MA in 1968, his PhD in 1968, and his SCD in 2005 from Cambridge University. After a postdoctoral fellowship at UC Berkeley, he joined the physics faculty in 1969. He received the Distinguished Teaching Award in 1983. He is a Fellow of the Royal Society of London, the American Academy of Arts and Sciences, the American Physical Society, the American Association for the Advancement of Science, and the Institute of Physics. He is also a foreign associate of the National Academy of Sciences and a foreign member of the Royal Society of Arts and Sciences in Gothenburg, Sweden. He has been a Sloan Foundation Fellow, a Guggenheim Fellow, and a Miller Professor on 3 occasions, not just one, but 3 occasions. He received the Charles Vernon Boys Prize of the British Institute of Physics in 1977, and in 1987 he was named California Scientist of the Year, and awarded the Fritz London Prize for Research in Low Temperature Physics. In 1998, he received the American Physical Society's Joseph F. Keithley Award for Advances in Measurement Science, and in 1999, the National Academy of Sciences Comstock Prize for Physics. He was awarded the Hughes Medal of the Royal Society and the Lau Nasmau Prize of the Helsinki University of Technology and Finnish Academy of Arts and Sciences, both in 2004. He was the UC Berkeley Faculty Research Lecturer in 2005 and received the Berkeley Citation in 2011. And I'm certain I have missed also some awards. A member of the Berkeley Physics faculty since 1969, John is now professor of the graduate school. For almost 50 years, John Clark has been a guiding light in harnessing features of quantum mechanics for practical use. He is the world's leading authority on the design, understanding, and application of superconducting quantum interference devices, commonly known as the mollusk, known as the squid. Squids are exquisitely sensitive magnetometers and amplifiers that serve as central components in a wide range of important technologies and scientific endeavors, from nuclear magnetic resonance imaging to searching for dark cold matter to investigating fundamental quantum properties. Today, we will hear from many of John's former group members. I wanted to give a brief synopsis and a little linkage to the talks that we will hear today. One of Clark's hallmark contributions, accomplished with then postdoc Michel Devereux and graduate student John Martinez, was the first demonstration of quantized energy in a macroscopic system. In fact, it says here a mesoscopic system. I think we will take it as a macroscopic system at this point. The debate is over. Their experiment demonstrated that the energy of a single Josephson junction is quantized, just as it is for atoms. And in John's own words, they showed that their junction really did behave as a quantum mechanical object. In an elegant set of experiments, the team demonstrated quantized energy levels and carefully noted the role of a dissipative environment. Subsequently, Andrew Cleland studied the effects of dissipation on macroscopic quantum tunneling in great detail. John and his postdoc, Dale van Harlingen, and graduate students Fred Wellstud and Christian Arbina gave life to fundamental studies of 1/f noise in Josephson junctions and squids, in particular fluctuations of the critical current and observed magnetic flux noise. Subsequently, Fred made great contributions to the development of high TC squids. John has collaborated with Per Delsing at Chalmers on studies of 1/f charge noise. Graduate student Rob McDermott has gone on, amongst many things, to shed new light on flux noise, while at Berkeley, Robert was working on ultra-low field MRI and MRI using both low TC and high TC squids. John and Gertjan have collaborated on a number of theoretical projects ranging from charge imbalance in superconductors to flux noise. And with John Mayman, who's sitting behind Gertjan today, the team studied charge imbalance induced by temperature gradients and built and used one of the first early scanning tunneling microscopes. Sherry Cho made important advances in understanding and reducing low-frequency flux noise in high-TC squids and magnetometers and used them as biosensors. John's work with postdoc Britton Plurd focused on flux qubits, their decoherence, and their behavior when they are coupled together. John's recent research conducted with Will Oliver and others at MIT and MIT Lincoln Laboratory has focused on a modified version of the superconducting flux qubit and on gaining a better understanding of the fundamental physical processes that lead to relaxation and decoherence in superconducting qubits. On a personal note, it has been a pleasure to have been your neighbor on the third floor, John, in Burge Hall for the last 11 years. We have discussed every subject under the sun, including the recent election. Okay. In that time, I don't remember any conversation that I didn't walk away from feeling that that was beneficial and pleasurable. And I hope you agree, I don't think there was a conversation where we haven't seen eye to eye in those 11 years. And that's really a testament, from my point of view, to the gentleman that you are, John. So the Department of Physics, putting on a slightly more official hat, with our chair also present here. The Department of Physics is indebted to you, John, for a life's worth of cutting-edge research, wonderful teaching, and meritorious service. I hope you enjoyed today's program. We are honored to be a part of it. And at this time, ladies and gentlemen, please join me in a standing ovation for Professor John Clark.